Hello, this is David again, and I am taking over from Zero for this lecture set, the first of 4. Today you are going to start dealing with material balances, and this slide serves as an introduction. Picture this in your mind: you have to purchase raw chemicals to feed into your chemical plant. As these cost a lot of money, you need to know exactly how much you are feeding into your process. You will be selling the product for a profit, so you will need to know exactly how much comes out of your process. If less material comes out than entering, it means that some of it is accumulating in your process. In this case, your tanks may overflow. And if more material comes out than entering, it means that it is depleting, or becoming less. If no material is left in your process, it would be a problem, as the process will stop, and you will have no product to sell. The reason for doing balances is not only to determine the flow rates, but also the compositions of the process streams. The mass in should be equal to the mass out of your process. Energy in should be equal to energy out. Except if your surname happens to be Einstein. Ha ha ha. An example of a physical process is the separation of two components in a feed stream. The production of ammonia by the reaction of hydrogen and nitrogen gas feed streams would be an example of a chemical process. There are 3 different ways to operate your process, and these are listed in this slide. For example, a batch of 1 ton of cement is produced after heating limestone for 4 hours. Once you are done, you need to start the process over again to produce the next 1 ton batch of cement. For semi-batch, there are 2 possibilities. For the first, only the product is collected as a batch. For the second, the feed is added as a batch. An example for semi-batch would be steam extraction of essential oil. Here 10 kilograms of plant material is put inside a pot, and then steam is passed through the material. The steam is condensed on exiting the pot, and the essential oil continuously removed from the condensate, until all of it is recovered. You would then reload fresh plant material into the pot, and repeat the process. Continuous means constant, uninterrupted, or endless. The good thing about a continuous process is that you need not stop and start the whole time. Your use of equipment is therefore more efficient, and you will be producing more product. Another way to classify your process is to look at the variables and see if they change with time. Steady means stable, unchanging. If your reactor is operating at steady state, the product concentration of the solution inside it would always stay at, for example, 20 grams per liter. I think the algebraic equations will be based on the formula, in, is equal to, out. Unsteady means not stable, or changing the whole time. From the essential oil extraction example, the concentration of essential oil, in the steam, will decrease with time, as the oil becomes depleted from the plant material. You therefore have an unsteady state. Following from your example, the concentration of oil decreases with time in the steam. Hence dC by dt drops. To find out how much oil is collected, dC by dt needs to be multiplied by the flow rate of steam, and integrated over the time of collection. This balance equation can be applied to batch, semi-batch, continuous, steady state, and unsteady state systems. Volumes and moles do sometimes change over a process. However, mass does not change. If the amount of a compound increases in your process, it is said to accumulate. If the flow of the compound into your system is greater than the flow out, the compound will tend to accumulate. If the opposite is true, and flow out is greater than in, the accumulation will tend to be negative, i.e. the compound will tend to deplete. If a compound is generated within your plant, this will tend to increase the accumulation of that compound, hence it is added to the expression. If a compound is consumed within your plant, this will tend to decrease the accumulation of that compound, hence it is subtracted from the expression. Consider the following example, press pause after it appears and try and do it by yourself. The answer will be provided in the next slide, once you press play again. Press pause now. You should use the general balance equation. No information is given about accumulation, hence this is what you could calculate. We have 50,000 people moving into the city in a year, and 30,000 moving out. 20,000 babies are born. 10,000 people become ancestors. 'Note that the balance is performed over the city, for a period of 1 year.